let's discuss the 15th question of the EOT. This is all about capacitance, and there is one basic formula which you need to remember, or one basic equation for almost all the questions. That is, you have Q, that is the charge, C is the capacitance, and del V is the change in potential. Usually the initial potential is 0, so this is not velocity, so please don't confuse with that. This is delta V, that is the change in potential. So if you make a triangle out of this, you get this. Q is the charge which has the unit coulomb. It is represented by C. Remember, this C and this C are different. This is capacitance. The unit is farad. This is the unit for capacitance. Generally, it will be represented in micro, milli, or nano. Milli is 10 raised to the power minus 3, micro is 10 to the power minus 6, and nano is 10 raised to the power minus 9. So if someone says there is a capacitance of 2 microfarad, what you mean by this is 2 times 10 raised to the power minus 6 farad. That is the capacitance. And del V is the change in potential, which is, the unit is volt. So let's take the first question. A 27 microfarad capacitor has, now capacitor is the device and capacitance is the capacity of that. So C is the capacitance, remember, that is 27 microfarad of this capacitor, has an electric potential difference of 45 volts. So I have del V, I have capacitance C. What is the amount, the net charge on the positively charged plate of the capacitor? So generally a capacitor has two plates. One is the positively charged plate, another is the negatively charged plate, and the charge on the two plates are equal but opposite. So plus Q and minus Q. So if they are asking what is the net charge on the positively charged plate, you have to find Q and put the plus sign. If they ask you what is the net charge on the negatively charged plate, you have to find the same Q but put a negative sign. That's it. So capacitor is basically a positive and a negative charge plate held together so that there is an electric field in between. Anyway, moving to the question, I have C, I have Q. I need to find out what is the charge on the positively charged plate. So if I need to find out the charge, Q will become, as per the expression, C times of del V. I have the capacitance which is 27 microfarad, so 27 times 10 to the power minus 6, and del V is 45. Multiply them, whatever result you get, that many coulombs. Or sometimes they will not solve the 10 to the power minus 6, they will simply say, let's say 27 times 45 is, let's say x microcoulomb. That's also correct. So either of the options, whichever option is available, use that. Moving to the next. Suppose you connect both a 3.3 microfarad and a 6.8 microfarad capacitor across a 24 volt electric potential. So imagine there is a battery, 24 volt. I connected a capacitor which is 3.3 microfarad, and another time I connected a capacitor. This is a sign of capacitor, 6.8 microfarad with the 24 volt. Which capacitor has the greater net charge? See, you don't even have to calculate it. Q is C times of del V. So if the capacitance is more, charge is going to be more if the voltage is same. So whichever has more capacitance, charge will be more here. Which capacitor has the greater net charge on its positively charged plate, and what is its magnitude? They want the magnitude also, so Q equal. For this one you need to calculate, you don't have to calculate for this. So that will be C, which is 6.8 microfarad times 24. Solve this, whatever that result comes, that many coulombs. That's the question. Remember this expression, that's it. Most of the questions will be solved. Question 59. You later find that the magnitude of a net charge on each of the plates for each of the capacitor in the previous problem is this. Which capacitor has the larger potential difference across it? You later find that the magnitude of net charge on each of the plates for each of the capacitor in the previous problem is this. Now, in this question, what they are doing is, they are saying that we have two capacitors. In the previous problem we had two capacitors. One was I think 3.3 microfarad and another was I think 6.8 something. Let's assume it was this. Of net charge on each of the plates for each of the capacitor in the previous problem is this. Now the charge on this and the charge on this is same. They are saying here also it is Q, here also it is Q. The value is this, 3.5 into 10 to the power minus 4. Which capacitor has the larger potential difference? If the charges are same, and if we go on the expression Q C del V, So which, if I find del V here, change in potential, it is Q over C. If the charge is same for both the capacitors, I'm not calculating, you can calculate also. If the charge is same as given in the question, it is same, which will have more potential difference. So I have told this before as well, that if we have A over B equals C, let's say, if A becomes more, C becomes more. But if B becomes more, C becomes small, because they are inverse proportion, reverse. So if B goes down, C becomes more, opposite. So here, whichever will have a lower capacitance, because it is the bottom, whichever will have a lower capacitance will have higher potential difference. So whichever out of the two will have lower capacitance for the same charge have higher potential. I will repeat it again. Whichever will have lower capacitance for the same charge will have a higher potential difference. Moving to the next question. Suppose that you apply an electric potential difference of 6 volt across a 2.2 microfarad capacitor. Okay, we have a capacitor, we have a electric potential difference. So what does the magnitude of the net charge? So first part is easy. Q equals C times of del V. C is 2.2 times 10 to the power minus 6 times 6.0, whatever the result we get. It would come out to be around 13.2 times 10 to the power minus 6 coulomb, or 13.2 microcoulomb. Both are correct. What does the magnitude of the net charge on one plate need to be increased? Okay, need to be to increase the electric potential difference to 15 volt. Now, they want you to find out the amount of charge. What does the magnitude of the net charge on one plate need to be to increase the electric potential? So this is the first situation, initial. Now in the final state, what I want the potential to be 15 volt. 15 volt. Initially the potential difference is 6 volts. Now I want the potential to be 15 volt. Capacitance is still the same. So I want how much charge I should increase to get the potential to be 15 volt. So what I will do, Q equals C delta V. I will find the charge, but they are asking how much is to be increased. So imagine initially it is 13.2. Let's say finally it comes out to be 20. So how much did I increase? If I had 10 dirhams and I have to get 25 dirhams, so how much did I increase it to? 25 dirhams, but what is the difference? So 25 minus 10. So this is the final charge, this is the initial charge. Just subtract them. Whatever the result comes out to be, that is the amount of charge which has to be increased to get to the final value of the voltage or the potential difference to be 15 volt. Moving to the next question. A sphere is charged by a 12 volt battery and suspended above earth as shown in figure 31. What is the net charge on the sphere? It's simple. Capacitance is given to you, del V is given to you, that is change in potential. So charge will come out to be C times of del V. Now this is a spherical capacitor. This is not the same capacitor like parallel plate. This is a spherical capacitor, but just remember it in the form of a charge. Like C I know, del V I know, I need to find out the charge, which will come out to be 5.3 times 10 to the power minus 11. Capacitance times the voltage, which is 12, multiply these many coulombs. That is the answer. Last question. I think so. You increase the potential difference across a capacitor from 12 to 14.5 volt. So it has been changed from 12 to 14.5 volt. Initially it was 12, finally it is 12.5, 14.5. As a result, the magnitude of the net charge on each plate increases by 2.5 into 10 to the power minus 5. So initially whatever the charge was, it increased by 2.5 into 10 to the power minus 5. So if initially it was X, the charge increased to X plus 2.5 times 10 to the power minus 5. What is the capacitance? Okay. This is charge initially. Okay. The voltage or the potential, it is 12.0 and here it is 14.5. The voltage I have increased. What is the capacitance? Capacitance here is C also, here also is C. I need to find out. If you look at the expression, capacitance is given by Q by V. So that means X by 12 here, because charge is X, potential is 12. So X by 12, this capacitance because it's the same device, so obviously the capacitance here also would be same. So here also I find the capacitance, that is x plus 2.5 times 10 to the power minus 5 over 14.5. Now because this is the capacitance, this is also capacitance, and we are talking about the same device, so just equate them. That means this should be equal to this. You can solve it using calculator. X by 12 here, x by 12 should be equal to x plus 2.5 times 10 raised to the power minus 5 over 14.5. You can do it with calculator. If you don't want to do with calculator as in like manually, so you simply multiply 14.5x equal to 12x plus 12 times 2.5, that would come out to be 30 times 10 to the power minus 5. 14.5x minus 12x will come out to be 2.5x, 30 times 10 to the power minus 5. And x will come out to be 30 times 10 to the power minus 5 over 2.5. Which is 12 into 10 to the power minus 5. This is x. Now x is charge. That is what I assumed. If I know the charge, this is Q. If I know the voltage V, I can find out the capacitance. So now the capacitance will become Q over V. Q is 12 times 10 to the power minus 5. V is, if we are talking about this situation, so it is 12. 12 would get cancelled. Charge will come out to be 10 to the power minus 5 coulomb, or I can also write this 10 into 10 to the power minus 6 coulomb, or 10 microcoulomb. I know it's a mess, but basically this is the microfarad, because we are talking about capacitance. It would be farad. So the capacitance would come out to be as 10 microfarad in this particular situation. No question? What is the magnitude of the net charge on each conductor plate of a 0.47 microfarad capacitor when a potential difference of 12 volt is applied across the capacitor? It's easy. Each conductor plate of a 0.47 microfarad capacitor. So I have the capacitance 0.47 microfarad, and a potential difference del V is 12 volt. I need to find out the charge. So charge comes out to be as C times of del V. C is 0.47 times 10 to the power minus 6 times 12. Whatever the result comes out to be, that many coulombs. That is the charge. The only point of confusion here is C is represented for coulombs also, capacitance also. C is the unit of charge, that is coulomb. And C is the symbol for capacitance, which has the unit farad. The symbol is F for that. So don't get confused between these two. Moving to the next, and that's it. So in this, one of the basic results what you need to remember, or the most important expression which you need to remember, it will be given to you in your exam as well, but you need to find out that what is given and what you need to calculate. That is Q, C, del V. And in your exam, you won't get the expressions in the form of a triangle. You would get something like this. And then from here you need to figure out. So you need to know how to rearrange the equations. Okay.